Hey guys, today we're going to do 3-2 solving systems algebraically. So our objective will be to solve linear systems algebraically. We can solve a system of equations by writing equivalent systems until the value of one variable is clear. Then we can substitute to find the values of the other variables. The first method we could use is substitution. And what we're doing with substitution is we're isolating one variable to then plug into the other variable. So we have a system of equations 3x plus 4y equals 12 and 2x plus y equals 1. So our first step is going to solve one equation for one of the variables. So you have to look at your two equations and think about which variable it would be easy to isolate. In our second equation, it would be easy to isolate y. So I'm going to isolate y. So I'm going to take my second equation and isolate y. So I'm going to get y by itself by subtracting 2x. Now y is equal to 10 minus 2x. So this expression is what y is equal to. I'm going to take this expression and substitute it in for y in my other equation. So instead of y, I'm going to write this equation. So 3x plus 4 times, not y, but 10 minus 2x equals 12. Distribute the 4. 3x plus 40 minus 8x equals 12. Combine like terms, negative 5x plus 40 equals 12. Subtract 40. Divide by negative 5. Negative 28 divided by negative 5 is 5.6. So 5.6 is my x value. Now we're going to substitute the value for x into one of the original equations to solve for y. So I'm going to take x and plug it into either the first or second equation. I'm going to pick the second equation, so I would do 2 times 5.6 plus y equals 10. 2 times 5.6 is 11.2. Subtract 11.2. Y is equal to negative 1.2. Now that I have x and y, I can write that as an ordered pair of 5.6 and negative 1.2. We could also use substitution to solve a problem. So, a music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music books, CDs, and software, are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? So 6 lessons is $300, 12 lessons is $480. So what it's saying is 6 times the cost of one lesson is equal to the one-time fee, plus the one-time fee is equal to 300, and 12 times the cost of one lesson is equal to the one-time fee. Oh my lord, so sorry. 12 times the cost of one lesson plus the one-time fee is equal to 480. So we can make the cost of one lesson and the one-time fee be two variables. So we'll let C equal the cost of one lesson and F equal the one-time fee. So now we have a system of equations. 6c plus f is equal to 300, and 12c plus f is equal to 480. I can easily solve for f by subtracting 12c. So f is equal to 480 minus 12c. Now I'm going to take that and substitute it into the other equation. So 6c plus 480 minus 12c is equal to 300. Combine like terms, negative 6c plus 480 is equal to 300. Subtract 480. Negative 6c is equal to negative 180. Divide by negative 6. C is equal to 30. Since c is equal to 30, plug that into our original equation. 6 times 30 plus f is equal to 300. 6 times 30 is 180 plus f is equal to 300. Minus 180 from both sides. F is equal to 120. So the cost per lesson would be $30. And the one-time fee is equal to $120. So we could use the addition property of equality to solve a system of equations. We can add a pair of inverses or subtract identical terms so we can eliminate a variable. So if we have the same coefficient and different signs, then we would add the two so that we would get rid of the one variable. Or if we have the same coefficient with the same sign, we would subtract the two equations. Here in our solution, we have 4x plus 2y equals 9 and negative 4x plus 3y equals 16. As you can see, if we added these two equations, 4x minus 4x would cancel. So I'm going to add the two equations, and I'm going to get 4x minus 4x cancels. 2y plus 3y is 5y, and 9 plus 16 is 25. Divide by 5, y is equal to 5. Since we have y, we're going to take y and plug it into an original equation. So 4x plus 2 times 5 equals 9. Subtract 10. 4x is equal to negative 1. Divide by 4. X is equal to negative 1/4. Therefore, my solution would be negative 1/4, 5. When you multiply each side of one or both equations in a system by the same number, the new system and the original system have the same solutions. So the two systems are called equivalent systems, and we can use this method to make additive inverses. So what we just did in the problem before is not always going to happen. We're not always going to have the same coefficient that would cancel out a variable. So we can multiply the equations by a number to get the same coefficient. So in equation 1 and equation 2, you pick a variable you want to cancel out. We're going to cancel out x. So what do I need to multiply equation 1 by to then cancel out x in with equation 2? I'm going to multiply equation 1 by 3 and equation 2 by 2. So 3 times 2x is 6x. 3 times 7y is plus 21y. And 3 times 4 is equal to 12. So this is my new equation 1. Then I am going to multiply the second equation by 2. But instead of 2, I could really multiply by negative 2. So then I could add the two equations together. So negative 2 times 3 is negative 6x. Negative 2 times 5y is negative 10y. And negative 2 times negative 5 is 10. So now I'm going to add these two equations because 6x minus 6x is canceled. 21y minus 10y is 11y. And 12 plus 10 is 22. Solve for y by dividing by 11. Y is equal to 2. Once I have y, plug into your original equation. So you could pick either original 1 or 2. 2x plus 7 times 2 equals 4. 2x plus 14 equals 4. Subtract 14. 2x is equal to negative 10. Divide by 2. X is equal to negative 5. Now that we have x and y, we could write our solution as an ordered pair, negative 5, 2. Solving a system algebraically does not always provide a unique solution. So just like when we were solving by graphing or a table, we don't always have to have one solution. We can have infinitely many solutions or no solutions. So when we have A, negative 3x plus y equals negative 5, and 3x minus y equals 5, I'm looking at these two equations and thinking to myself that elimination would work best. So if I add these two equations, I would get negative 3x plus 3x is 0. Y plus negative y is plus 0 is equal to negative 5 plus 5 is 0. Since 0 is equal to 0, that is a true statement. This means we have infinitely many solutions. And then in B, I once again have similar coefficients, so I'm going to add the two equations. 4x plus negative 4x is 0. Negative 6y plus 6y is plus 0 is equal to 6 plus 10, which is 16. Since 0 does not equal 16, this is no solutions. You guys try this one.